Back to today's theme. The IRF, resilience is not a standalone topic. It is a thread that runs through everything we do. Our work with governments, development banks, and industry partners consistently highlights one truth. A road network is only as strong as its ability to withstand shocks, adapt to change, and recover quickly. Whether those shocks come from climate impacts, operational disruptions, or the growing intensity and complexity of mobility systems, resilient road networks are the backbone of sustainable transport. Resilience thus spans several real-world dimensions. Structural resilience, ensuring that infrastructure is designed and built with durable, fit-for-purpose standards. Operational resilience, making sure networks continue to function during crises, supported by redundancy and smart systems. And climate resilience, which is rapidly becoming non-negotiable as floods, landslides, heat waves, and extreme weather events reshape risk profiles around the world. To put the challenge into perspective, we heard in our opening session yesterday how the World Bank estimates that the cost of road maintenance will triple in the coming decade on account of climate impacts. Our UN keynote speaker, Dmitry Maryasin, went a step further by stating that no roads should be built without resilience in mind. What does this mean in practice? Well, to help answer these questions, today's panel brings together leaders working on every one of these dimensions, from engineering and climate modelling to intelligent operations and materials technology. Their combined experience spans East and Central Asia, Europe and the Middle East. I will not read their full biographies, which are extensive, but let me introduce them briefly in the order in which they will speak. Hemant Tiwari, Transportation Engineer and Senior Transport Officer at the Asian Development Bank's resident mission in Nepal, with broad experience in planning, traffic engineering and resilience across the country's mountainous context. Danilo Ebbinghaus, Climate Resilience Expert at Oris, specialising in climate impact modelling, extreme weather risk assessments and climate-ready design methodologies for road infrastructure worldwide. He will be followed by Damon Butters, CEO of TDRI Solutions, whose subsurface measurement technology and recent IRF Startup Label Award winner, congratulations again, is helping engineering teams tackle one of the biggest threats to pavement durability. Martin Flegel from Flegel Baucom bring in insights from materials engineering, heavy machinery solutions, and the operational side of resilient construction. And last but not least, Jerry Hu, General Manager of Huawei's Smart Transportation Business Unit, leading smart road deployments across China, the Middle East, and international corridors, including large-scale ITS and digital twin solutions, and we'll hear the role these play within holistic resilience strategies. As with our previous sessions, we will begin with 5-minute opening presentations from each panelist who have kindly agreed to limit the number of slides they will be sharing before moving into a moderated discussion and questions from the audience. And as a reminder, if you've just joined the conference for the first time, please use the Q&A feature throughout the session to get your questions to our esteemed speakers. Thank you all in advance for keeping the time limit. Hemant, the floor is yours, I believe. So if you'd like to open your camera, we will walk you through your presentation. Thank you. Hemant, you are currently muted.
So I am audible.
You are indeed.
Thank you, Brendan. So I will be touching on the context of Nepal actually. So we will touching on the aspect of structural resilience and operational resilience. So maybe I am Hemant Tiwari and I represent Asian Development Bank. At the same time, I also represent one professional society in Nepal, Society of Transport Engineer Nepal. And today's presentation will be basically from the transport engineering perspective and this is my personal view rather than the organization view. So we can go to the next slide, please. Yeah. So actually, if you Nepal, actually, if you know about Nepal, it's a small country, but the elevation there is a wide range of elevation difference from the low elevation up to 60 meter and the highest elevation of 8,848. That is Mount Everest lies in Nepal. So this trigger a major issue in Nepal, the slope cutting and everything. So this with this the landslide come to be a major challenge in context of Nepal. Not just landslide, actually we do have issue of flood. So on the lower area, we have issue of flood, and in the higher area, we have issue of landslide. So these are some of the picture I just want to highlight. In last year, every year we used to have massive rainfall, 2 day, 3 day, all over the country. And this is the some picture from the last year rainfall. So in the if you see in the map of Nepal, it so that the rainfall affected most of the road in almost all part of the country. So just to give you a glimpse that even the 3 day rainfall all over the country has affected almost 41 major road section, strategic road section, not just local road, strategic road section, and it has significantly impacted road. And one of the lifeline of the road was blocked for almost 36 hours. So we can imagine how loss is there, and it can also shown in the picture. And there is a organization which estimated that almost 200 million was million USD was the estimated value of the loss due to just a 3 day rainfall in context of Nepal. So this showed how we face a challenge on the structural resilience in context of Nepal, and it's maybe we can say that it need to be further elaborated in the next slide. Can you go to next slide? Yeah. So on this aspect, actually, the next step in context of Nepal, actually, we are getting because we are low and middle income country. So we are now focusing on safer road. Initially, I was thinking what to build more road, but now we are inclined to a safer and resilient road. So first step will be climate resilient and smart design. So we can see that most of the due to hilly terrain and due to slope stability, most of the issue is related to slope reinforcement, and it need to be encountered with the proper bioengineering techniques, drainage management in not just in the hilly area but also on the lower area. Then it should be properly backed up with national standard. As of now, we have road design standard, but we do not have the climate resilient or proper design standard that link with the slope stability and other thing. And it should also be linked with multi-hazard risk assessment in the planning. So for this, currently ADB, World Bank, and ADPC is also working on this part. So this is the first step, and now we are approaching on that part. Next, we need to use for the technology. So some of the speaker will touch on the technology, and it should be customized in the local context. So use of local available sensor need to be there for early warning system that can be used for landfill monitoring, and it can be also be a tool for the better decision making. As you know, we are a lower middle income country, so we lack financial stability. And now ADV, World Bank, and funded project are being introduced with PBM, performance based maintenance contract, embedded in the original contract. This will make sure that the maintenance will be there from the contractor responsibility. So this is something we are approaching, and we are moving in the direction. And later on, we will move towards the area based performance based management contracts and other thing. And because of the major issue, we need to promote low cost bioengineering techniques, and we need to use up local material, local resources, everyone which is available in the local context. And this need to be strengthened local and rural emergency response system, which we have been facing in the current scenario. And UNDP and other organizations are also supporting in this part. And finally, if available, we are promoting and advocating for the dedicated resilient funds in context of road maintenance and asset management and other sector. So these are some of the forward looking contribution that will work on the tasks. So maybe we can go to the final. So on this part, we will be focusing on the climate resilient design on the prospect of road resilient, working on the structural and operational resilience. We have not touched on the financial sustainability and other things. Thank you so much.
Thank you, Hemant. And I think the presentation we've seen is a testament not just to the resilience of Nepal's transportation system, but indeed the resilience of your engineering community and your ability to kind of build back roads in these very kind of challenging circumstances that we've seen. Thank you for that, and we'll come back with a couple of further questions if you're willing to continue sharing your expertise in just a few minutes. I think building on maybe some of the insights, Hemant, you've shared, we're now going to hear from Danilo Ebbinghaus from Ars Materials Intelligence if you wish to join us. And I'm sure that what you've heard may sound familiar to you, and perhaps you provide part of the solutions, so the diagnosis at least. Thank you.
Yes, for sure. Thank you very much, Brendan, for moderating this very interesting session, panel discussion. Yes, thank you very much, Hammond, for your first presentation. I think it's pretty much a very good painting to start with after this great presentation. So I'm going to present you a systematic framework for developing a prioritized adaptation roadmap for a specific project in Cameroon. Is about bypass around the Yaoundé city. I'm Danilo Imbinhaus. I'm the climate resilience expert at Oris Materials Intelligence. And for me, the final goal with this presentation is actually to give you some insights on how digital services can actually help us improving the resilience of road infrastructure projects. Can go to the next slide? Yes. So for every infrastructure project in general, what we at Oris Materials Intelligence try to do is actually to fill the gap between the current process that we have and what AI and data can bring to the table. So if on one side we have very resource intensive and slow tasks and manual procedures to actually get assessments done using global course data and qualitative risk flags, we have the opportunity to use AI and data to have more precise quantitative risk classification using regional precise data, downscaled up until the kilometric point of the project alignment, and of course, culminating to a rapid assessment, which is basically the image that you can see right in the right bottom of this presentation. So this frozen part is actually the list of the adaptation to the left listed for the bypass highway project, and specifically showing a critical point of runoff around along the alignment. But how did we do this? So you can go to the next slide. So basically, the approach behind this tool that we used for in the case of this project is all about data and AI. So we started considering the project context, so gathering the data for about the project components and the project alignment. And in the climate screening and vulnerability assessment, what we did was we mapped 28 different hazards. We identified potentially vulnerable components along the project alignment. And for those vulnerable components, we passed to the adaptation selection phase, where we actually got to select out of ORI's comprehensive adaptation database containing more than 700 measures, a very few fine-tuned measures specifically for the context of this project. You can go to the next slides. I'm going to drive you through a bit of the advantages of using this digitalization approach. So, of course, as you may imagine, digitalizing accelerates everything, and AI even more. So for this specific project, we got from more than 700 measures from our database to a shortlisted 33 structural and non-structural measures, and including 9 measures that are already aligned with the preliminary design, 20 measures that were not aligned, providing clear pathway for a better adaptation of the project. And even for the measures that were already aligned, we were able to provide climate-proof justification for them. And of course, we considered as well nature-based solutions, which were part of our database of adaptation measures. And in the case of this project, it accounted for 0.8% of the project budget. So as a final conclusion, I would just like to say that, well, it accelerated, it got a more efficient due diligence of the project. And one very important step here is actually the capacity building and local ownership, because those kind of tools is not here actually to replace our expertise, is actually here to empower local ministers, clients, MDBs, and engineering firms to get to take ownership for their resilience projects and get more resilient results for specific projects. So I'm very happy to discuss more. I know this is a very short presentation and quick, so thanks very much.
Thank you, Danilo. And I'm glad you mentioned empowerment and capacity strengthening. I suspect these are topics that we'll be getting back to as part of the Q&A. And, clearly a lot of what we're doing today, forms part of that process. So thank you for that. Danilo, I will now call on Damien perhaps to join us. Let me just make sure. And we are going to talk about some of the threats to the durability of pavements in particular, and the role that moisture plays. So Damien, you're online.
Great. Thank you so much, Brendan. And yes, looking forward to speaking to you all about the three biggest challenges that we hear civil engineers have with managing roads, both existing and in new construction. And of course, those three problems being water, water, and certainly water. All right, next slide. Thank you, Brendan. So TDRI was very fortunate to receive the the IRF startup label at the global conference last year, and that has really given us an opportunity to accelerate our understanding of the real challenges with moisture globally. We are based here in New Zealand, and that's where we originally developed this technology and understood both the challenges and the opportunities with subsurface moisture measurement. Now, it was actually a 7-year-long study completed here in New Zealand, where primarily we build chip seal roads. We don't have significant depth of asphalt, and so we're pretty susceptible to all types of damage, particularly including moisture. Now, the study actually realized that areas with excess subsurface moisture were failing 2.5 times faster than those without. So we were taking what could be a 25-year design lifetime, and we were lucky to get 10 years out of a piece of road. So the opportunity for improving socioeconomic outcomes and spending less money on rebuilding roads sooner than necessary was very real, and the impetus to develop this technology was largely because of that. So what we actually have is an extension of time domain reflectometry, which is your standard soil moisture probe technology. But using an antenna system, we're able to measure up to 0.5 meter or 18 inches under the road surface a moisture content at full traffic speed. And that's very unique in that we can now create large maps of subsurface moisture under roading very quickly. Next slide. Thank you, Brendan. An example of where this has been used recently, and as we move into, as I say, other countries, we also understand some of the opportunity here, particularly related to the management of climate risk, and in particular, the generation of climate adaptation plans. So the County of Beaufort in South Carolina has some significant challenges with the coastal risk to many of their residents and their roads. And they actually had a local consultant complete a vulnerability study. And the modeling that was used in this vulnerability study provided them risk to each of their road sections. And what they were able to do is now ground truth that modeling. And this is an extension of what the ORIS team mentioned around having the localized data now to provide very accurate understanding of the real risk to those roads today that can validate what that modeling is providing, and then also give you an opportunity to take action in the real world now to try and mitigate some of that risk. And so the simplest way here can be that we can do something that's relatively cheap right now to address drainage issues. We can then plan for improved drainage in the future. And then when we go to do perhaps a full rebuild or even new design of roads, we can get the moisture levels right from day one. Next slide. Thank you, Brendan. So again, the opportunity here really is that by now being able to create moisture maps for entire city and region road networks very quickly, we can use moisture as a standard input into maintenance and predictive lifetime modeling to actually start being proactive about what really is one of the major factors in road deterioration. And again, we can take the opportunity here to reclaim that 2.5 times extension in road lifetime by understanding moisture levels now, mitigating them with a prioritized plan for drainage maintenance rather than a cyclic one, and then planning for something that is fit for purpose from a drainage perspective when we go to do rebuild or new design work as well. All right. Thank you very much for your time.
Thank you, Damien. A number of points that we'll be getting back to in the Q&A, including on risk management and ownership. And if you'll notice, there's in fact a question in the Q&A about just this topic. We will get back to that. We will, for now, move along the road value chain with a presentation delivered to us from Fliegel Baucom in Germany. And I will encourage Martin to perhaps open his camera and his microphone so that we can begin his presentation. Martin, welcome.
Hello. Thank you for introduction. My name is Martin. We make worldwide research in road construction. There are investment billions of dollars for infrastructure. The contractor invests several $million for asphalt mixing plant, for machinery equipment on the site, but nobody takes care about the impact, how the asphalt mixes coming from the factory to the site. I will show you some research projects. In the praxis, when asphalt mixes coming to the site, there are the first 5 tons of material are cold. Segregation is a big problem, a huge matter for sustainability. If you look on in the praxis, the first 5 tons are at least 30, 40, sometimes 50 degrees colder. And then with every truckload, if you know 20, 30 ton per truckload, you can calculate in advance how many meters distance is a big matter with the temperature. And with the temperature, it's not in the same range, it's impossible to get a correct compaction. Also, mechanic segregation, it's a big problem, a big matter. So it's impossible to get an even compaction. Please, the next slide. And if you, how you can see here, that the first 5 tons are cold. When cold material with cold will be mixed together, then behind the paper, it's a big problem. A lot of research and studies all over the world has shown that the transport vehicle has an important impact about the quality what comes out of the paper. Even a feeder cannot remix the material. It's impossible. The next slide, please. On the right side, you can see every 5 meter district, the average temperature behind the paper. And here you can see that the temperature went down 20, 30, 40, sometimes 50 degrees and more. Then with the next truckload, sometimes 20, 30 degrees, and so on. On the left side, on this screen, you can see the asphalt from the same factory, from the same weather conditions, with horizontal discharging. With horizontal discharging or with push-off technology, it remix every truckload, slice by slice, like slicing salami. So the temperature and grain structure, it's much more even or a bit better distributed. Even pavement, even grain structure from the corn sizes and process reliability. And that's, for instance, a research from Austria, from Vienna, on a road project, but also in Berlin, in a lot of universities has been done such researches. The next slide, please. That's the question. If infrastructure projects will be made, what is for future important? Mainly to save a few cents per square meter, but have a lifetime from the infrastructure from 5, 6, 8 years, or invest a few cents more per square meter and rise up the lifetime, have at least 50% more lifetime, service lifetime. The pavement, it's much more smooth. Also process reliability, no conflict with the height. If there's some, for instance, on an airport rehabilitation, even in operation from the airport, or in the city where power lines above. Also another point, health and safety. This vehicle cannot fall over to the side. It's a very important point for health and safety, and increase the sustainability and active possibility to reduce the CO2 emission for the project. So this technology, it's standard all over the world. More and more road authorities, highway authorities are doing or implement this in tender procedure. It has to be in the tender like a must or as a bonus system. Then also the contractor will use it, and it's a win-win for all participants, for road users, and good infrastructure. It's a base for positive economic development all over the world. And so it's an active point for more lifetime for environmental protection and so on. The next slide. Thank you very much. If there are any questions, I will send also the contact details now in the chat. If there are any questions, it would be a pleasure to send you some information, and doesn't matter on which continent, to support for your upcoming projects for more sustainability for infrastructure projects. Thank you very much.
Thank you very much, Martin, in particular, for highlighting the role that transport and construction operations play in improving, I think, the properties of the road surface, and therefore it's longer term, longevity in a sense. For our final opening round of presentations, I will now invite Jerry Hu, the General Manager of Huawei's Smart Transportation Business Unit, to join us. And we will now move from the design to really the operation of existing networks and what resilience means in that context. Jerry, if you can open your camera.
Yes.
You're very welcome to begin. I apologize for that mix-up in the slides. Yes, there we go.
It's okay. Okay. Thanks, Brenda, and we're honored to have this chance to share our experience in this webinar. Okay. Next. Okay. Next, please. Okay. Please just allow me to introduce our company. Actually, I'm from Huawei. Huawei actually already have 30 years of dedication in transportation. Started from last century, where providing transportation system to the road operators. Now, currently, we are using the latest information and intelligence technology like AI, like 5G network and big data and cloud platform. With those technology and with our partners, we are serving for the seaport and logistic and warehousing companies, and also serving the railways and serving the roads, and also aviations for the comprehensive transportation. Next, please. Okay, this slide is a little complicated, but I just want to explain that smart road business unit is the major focus within Huawei Smart Transportation business unit. Okay, and within smart zone, we are offering like the digital and intelligent foundation based on and also based on the traffic engineering management technology. It's a combination of digital technology with engineering, with traffic engineering solution to provide the scenario-based solution to the operators. And I will show two cases for you. Okay, please next. Okay, this is the first case, how to improve the operation resistance with smart technology. You know, usually in China, there are a lot of highways that are facing like a capacity limitation. They need to do expansion, like expand from 4 lanes to 8 lanes. But with those physical expansions very expensive, it will cost around 200 million Chinese yuan per kilometer. That's very expensive. But with some digital information technology, we just maybe cost around 2 or 3 million Chinese yuan per kilometer. But also we can include the capacity around 10 to 20%. How to achieve this? First, because we know they have a usually caused congestion because of accident or like the car problems. If we have such kind of accident happen on the road and cannot be detected quickly, then this will waste the time. Previously, those car accidents and usually done with human, but now we introduce the AI and real-time AI-powered detection technology. You see, we can detect the traffic flow and the vehicle density, and also we can detect the traffic accident and the traffic congestion. We can shorten the detection times from 15 minutes by human to 10 seconds with AI technology. And once those accidents or incidents detected, that's secondly, we are going to introduce AI technology to provide the proactive control with automatically generated measures. Previously, those measures was usually experience based, and they need the operators have a very good experience. But if the operators they don't have very enough experience, that the measures will not be effective. Now currently our system can automatically generate those measures like the dynamic speed limit control and rapid dynamic control. Such kind of measures can be automatically generated in a short time, and this will improve the congestion issue. And the final step, once the measures is generated, it anyhow is needed to be implemented by human, right? Previously, the collaboration between those operators and the traffic policemen, it was separated and independent system. The efficiency is very low. Now we have one integrated command and dispatch system. The mayors will be automatically distributed to the different departments with one unified platform. This will shorten the response time. You see, we have a rare case in Jiangxi. This is one highway in China. We are shorten the response time, also improve the load operation resilience. Okay, next please. Next slide. Okay, this is the final slide. This slide I will share one case of the regarding of the climate resilience. This is a real case in Shenzhen. You know, Shenzhen is a south city, the southeast city in China. It's close to the coast of West Pacific Ocean. Every year, in the September and August this season, we are facing very several climate events such as hurricane or typhoon or rainstorm. Once such kind of accident, this very climate event happened. Usually, those kind of evacuation of people and the traffic management was done by human with very low efficiency because we need a lot of different kinds of collaboration. First, from the mayor, then to the management of different districts, then finally to the street. It takes long time and the efficiency is very low. Now we introduced one intelligent system. First, the system is integrated with we call it intelligent warning. It can update the latest climate information and then can generate the we call it early warning. Once one hurricane is coming, this will generate early warning, and based on the level of the hurricane, then we have 11 types of contingency plan. This with those contingency plan, we can automatically generate the measures. And second step, we can one click to have to establish one joint meeting just by one click, and also we have the intelligent resource matching, and also we can support the remote video command here. Then the task alignment is just a centralized command, and the task allocation is just very short time. Finally, even after this event was handled, we can introduce the AI model to generate the pre event report, help to do the management and review. And with this system, you can see we can shorten the response time from 30 minutes to 5 minutes. And every year we can support more than 10 times of climate event response every year for citizens. And this will help to reduce economic loss and people damage. Okay, thank you. If you have any more questions, you can just send me questions. Okay, thanks. Thanks, Breda.
Indeed. Thank you. Thank you, Jerry. It's
Mm.
very impressive to see all these technologies coming together at the surface of operational resilience. We now come to the panel discussion, and in the meanwhile, please, we'd like to see perhaps more questions come in through the Q&A box, and I'm going to invite all our panelists perhaps to reveal or uncloak themselves, once again, as we start with a few rapid-fire questions. So you're very open. Well, in other words, you're very welcome to open your webcams. And I'm going to start with a first set of questions, perhaps directed to Hemant and Danilo, because both of you addressed case studies in low and middle income countries. These are typically the countries that face, a dual challenge, the heaviest climate impacts, as obviously we saw in case of Nepal, and frequently the tightest resource constraints. Based on your work, we'd like to know, in your view, what locally developed approaches, data tools, or engineering practices show the most promise for strengthening resilience, especially given some of the challenges that we've seen with budgets, terrains, or institutional capacity, where clearly these impose a number of limits, on the engineering community. So, what in your view are the most appropriate, the most suitable, the most scalable locally developed approaches to these challenges? Hemant, let's perhaps start with you and then moving straight over to Danilo.
So thank you, Brendan, for the question. So actually, in context of Nepal, so as we are low developed countries, basically we are focusing on the low cost effective measure. Actually, either it be bioengineering techniques. So we have developed some bioengineering measures in context of Nepal. At the same time, we are also customizing some low technology tools, because even for the landslide monitoring and other things, we have the advanced tool that we cannot brought in context of Nepal because it's too costly comparing in national economics. So we are customizing those thing, and the most important thing in our context will be capacity building. So we need to develop manpower, human resources, that will be work on the both engineering aspect as well as on the technical aspect. So that is something we need to build on. So we cannot always rely on some grant or other money. So we need to build on this capacity building. And now we are piloting some of the case study on the low cost effective bioengineering techniques, civil engineering structure, and with support from donor agency in the past, we were able to develop some guideline in bioengineering techniques. Now we are moving towards on the technology part. So we are developing some low cost effective technology. For example, this lens early warning system for landslide management and this thing. So we need to customize in context of Nepal with much more focus on capacity building and developing local expertise. Thank you so much.
Thank you. And Danilo, perhaps you'd like to maybe expand on what we've just heard. Thank you very much, Hemant. Oris, obviously, you've developed your simulation software in a number of national environments, and perhaps you have some additional insights that you would wish to share.
Yes. Well, what I liked very much to hear also from Mr. Hammond was the capacity building need in those countries, because we're talking about, as you mentioned, low income countries. And one very important thing is actually the collaboration with local design companies to get able to implement properly the resilience measures. One main issue that we usually face is the fact that at the preliminary design phase, we don't actually have resilience measures put in place or actually designed to be reviewed in the detailed design phase. So this collaboration with all the stakeholders is important for us to discuss together to actually put in place already in the preliminary design and ideally in the prioritization step, even up front, for us to understand better actually what will be the investment. And of course, this will deal in the future with less cost of maintenance, dealing, of course, with operational resilience in the further steps. But this is the most important step, I would say.
Thank you very much. We'll turn over to Damien, perhaps. So you obviously highlighted how subsurface moisture could often be understood as maybe an invisible trigger of failure, deformation, and premature maintenance. So as weather patterns become less predictable, where do you see the biggest gaps in how agencies currently diagnose and manage, some of these hidden risks? You don't always, see moisture when you look at the surface of the road. What practical changes could dramatically improve pavement resilience? And I'd like, if I may, to for you also to have a go at one of the questions that came through regarding um, the ownership, the distribution of risks, and perhaps you see that question in the Q&A box. And I think it doesn't just apply to PPP toll roads, but to infrastructure in general in terms of perhaps drawing from your experience in New Zealand or other countries where TDRI is present, where the responsibility falls, ultimately when road failure occurs.
So to wind back to the original part of the question there, I think one of the biggest challenges that we see today is the fact that so much of what has already been built is pretty poorly quantified by today's data standards. And so just trying to understand what you already have so that you can manage that properly is a massive problem. Now, couple that with the fact that the environment has been, of course, changing, particularly under the road surface, the scenario for you. It creates a significant challenge for those organizations and those road owning entities to have any chance of even maintaining the status quo, let alone getting ahead of a number of those challenges. So I think as many people have echoed here, data and the timeliness of that data is absolutely critical. Now, moving to the question there around the the returns and the shift of climate risk. Yeah, look, that's an interesting one. And here in New Zealand, it's quite relevant because we've been discussing much more actively the public-private partnership piece. It's something that we've done barely a handful of times here in New Zealand, much more common in other countries. And certainly the returns piece and the opportunity to be more prescriptive on the quality that can be achieved, and a number of case studies that have proven that PPPs can provide better quality have been used as examples to justify moving forward with them. I think the both challenge and opportunity here is that has probably historically been a lack of prescription around the ownership of climate risk, and probably to a degree of the changes over time of traffic intensity, such that there is a gray area in the long-term management of those contracts that may mean that it's not a clear responsibility for those road owners in that partnership as to how to move forward with spending the right money in the right place at the right time.
Thank you very much for that, and apologies for putting you on the spot with what I know is a complex question with many different answers, and one which we're still learning about, frankly, as you pointed out. These were not traditionally risks that were really integrated, within financing agreements, whether PPPs, build, operate, transfers, or such like. Thank you for that. Focusing now on digital operations, perhaps turning to Jerry. So you've highlighted obviously a number of smart road solutions. And what we'd like to hear from perhaps is which digital capabilities, from your vantage point, and we've heard about predictive monitoring just now, but also AI-based analytics, integrated operations centers, as you displayed in your presentation, which of these, in your view, deliver the strongest real-world gains in terms of keeping roads open and safe during disruptions?
Real gains in terms of capabilities. Okay, Braden. And actually, what I was saying is, from our perspective, our understand our knowledge, I think we think the information and intelligent technologies going to play a more and more important role for the road resilience, and it can perhaps in two perspectives. And firstly, with the AI technology, because for the road resilience, sometimes if we cannot detect the accident or car crash in your short time, it will usually cause second time like crash again. This will cause death or problems. Also will cause very longer or very much more serious congestion. And then with AI technology, we can shorten the detection time, and this really helps. This is firstly. And secondly, previously, if the car accident or congestion happens, it's usually need a very rich experience to handle such kind of issues. But now with the AI technology, we can extract those experience from the rich experienced person and to transform it to machine learning algorithms. And with those algorithms, even a fresh guy, they can handle such kind of accidents in a very short time and in the right way. And this will lower the requirement for the human capability. And this is second. And certainly also we are going to introduce like the convert the information system, because very complicated traffic issues usually need a lot of different department collaboration. But now this usually takes time if the efficiency is very low and the collaboration is not very good. But now by adopting the information technology, we can just put all the guys, all the different different departments in one system. Then they can shorten the response time and improve the collaboration efficiency. Okay, that's my experience.
Thank you, Jerry. Yes, very, very insightful indeed. Martin, we'll turn to you for the final question, and this time coming from the audience directly, as opposed to one of mine. And perhaps you see the question, but if not, let me read it to you. It comes from Turkey. If we use one mix asphalt, can we achieve measurable cost savings over a 25-year service life? Martin, I don't know if you want to have a crack at that question.
With the use of push-off technology, of course, the quality and the homogeneity, it's much, much better. It also brings a possibility to transport the asphalt mixes not only half an hour, and even 3, 4, 5, 6 hours and more transporting time. It's no problem because the complete truckload will be remixed. And if it's coming even distributed from temperature, from grain structure, so the service life is much, much more. Only with use of push-off technology and also with lower temperature asphalt or warm mix asphalt, even there you have much better lifetime of the pavement. The use of push-off technology alone, of course, cannot always guarantee 25 years service lifetime when big other issues are happening, of course, because there are so many problems what may happen on the side, but it's a revolution. It is a milestone for process reliability, even if other problems are happening. So it helps you to even share to make a very good road and much longer, like with tipping trucks.
Thank you very much, Martin. And building on that, I think that, as you said, it helps but it doesn't take you all of the way there. You will still need, regular pavement surveys. You will still need, dedicated maintenance budgets, which really brings me to my final question, which I'd like to raise with all the panelists as we kind of progressively wrap up today's panel. So, IRF publishes World Road Statistics every year, and this year's edition reveals that road investments and maintenance budgets are declining, sometimes quite significantly, across many countries, including Germany, I'm sure, as Martin will agree. So, there's less funding going into the system, even as expectations for a resilient and reliable network continue to rise. So, I'm going to ask each of you how we reconcile this gap in practice with just one very short response. Martin, perhaps we can begin with you.
What's also a point in the last decades, the average service lifetime of roads from new build roads or rehabilitated roads are not rising up. No, it's getting sometimes worse and worse. Also, the bitumen content, or there are different, many different reasons. And so that's the point, how to implement modern technology to bring process reliability and bring much more lifetime back again. And so through this, so the transport vehicle itself, it's a very small piece in the chain to build road, but definitely it's a revolution for the whole process. Also from our side, we make several thousand vehicles every year to all continents, and it would help and would be a pleasure to support for the upcoming projects.
Thank you, Martin. So I'll now move to the other speakers, perhaps in the order they spoke in. Hemant, how do we square this circle? Less funding available for maintenance. I mean, you highlighted the need perhaps in your presentation for a dedicated, road resilience budget. I don't know if you have such a budget, if one would become available. So how do we overcome this challenge in your view?
Actually, in context of Nepal, this is a major challenge. So maybe the current mechanism is that we need, if we can involve this maintenance, 5 8 10 maintenance as a part of the contract itself. So it will be some of the opportunity. Otherwise, I think in context of Nepal, it's a major challenge. And the second aspect will be to have with this sustainable launch, sustainable decade starting from 2026. Hope it will embed it in the design itself. So because we can witness from the decade of road safety 2010 to 2020 and 2020 2030. So this road safety embedded in the system. So we are expecting this climate resilient maintenance will be embedded in the system, and the country will prioritize to some extent. So in this way, we can reduce the maintenance gap actually.
Thank you for that. Danilo.
Yes, well, I'll answer that having in mind that we just had the news about the COP30 ending, and the adaptation finance gap is still there. We still have to shrink it. And in my point of view, the solution for that is actually getting to have estimation of the investment upfront and upstream in the life cycle of a project. And how to do this is simply by implementing digital tools, data-driven digital tools in the upstream of the climate or the project cycle, just like the one that I presented.
Indeed. Thank you for that. Damien, would you like to come in?
Sure. Look, I think the shrinking budget and the increasing severity and frequency of climatic events, pun intended here, is a perfect storm. And so we're not going to make any improvements by continuing to do things the same way that we've always done. And so a big part of the challenge is just a mindset shift towards looking at alternative ways of doing things. And everybody today has presented critical parts that add up to a much bigger increase in potential lifetime, improvement in resiliency, and an opportunity for actual adaptation here. But the implementation of those things has to happen incrementally. We know that there isn't more money to do this. So making some very careful selections around what will and won't be done. And again, if we can do things proactively and spend less to get more, we're going to start to get ahead of these problems.
Outstanding. Thank you, Damien. And Jerry, I'll let you have the final word. Well, China has significantly developed its road network. Its maintenance needs today are huge. Can the type of digital solutions that a company like Frare develops Can they help stretch those maintenance budgets in any way?
Yes, yes. Actually, this is a very good question. And also, China is facing such kind of challenge, because China built a lot of highways uh, almost 2 decades ago. Now, in China, the more and more highways are getting aged, and they need a much more maintenance cost. But actually, in China, the toll collection is only can only have 30 years. So not those operators, they are facing such kind of challenge. I think, as per my perspective, I think there are two kinds of measures. Firstly, there maybe need some toll collection revolution. Maybe the government should allow to expand the limitation for toll collection. That's the first way. And also the government should provide some allowance regarding the maintenance. That's the firstly. And secondly, I think most importantly, we should consider to introduce some digital technology. For example, with digital technology, we can improve the maintenance cost, like for the home cost. And also we can evaluate the maintenance period based on the traffic volume, such kind of technology. I think, and Huawei is also studying such kind of scenario-based solution. Okay. Thanks, Breda.
Thank you very much. It sounds like we all hold a piece of the puzzle, and Jerry, I'm glad you mentioned road user charging or smart tolling in particular has kind of been perhaps one of the pieces of that puzzle. So we've come to the end of our panel just in time. So thank you everyone for sticking to your allocated time. So thank you for these excellent and, as you've seen, complementary contributions. We've seen, obviously, we made it clear, I think, in the panel that resilience is not a single discipline. It's a combination of, as we saw, engineering, data, materials, finance, capacity building, and operational readiness. And clearly, when these dimensions come together, countries can protect their investments, ensure continuity of mobility, and prepare their networks for a rapidly changing climate. So, on behalf of the IRF, thank you for being part of this important conversation. And we look forward to continuing these discussions both during the remainder of the conference and, of course, throughout IRF's programs. So please join us in just 16 minutes now for our next session on efficient roads for smarter cities. Thank you very much, everyone, and have a great rest of the day.